Hello, my name is Henry Huang. I'm an investment director with TDK Ventures. I will start the first question as, what do you think is the most impactful innovations in computing and connectivity in the next 5 years? Maybe start with Diane.
When I think about the tremendous growth that we've seen in actual real-world deployment of AI over the past few years, it's dramatic. I mean, I remember the first time I got up on stage and said artificial intelligence, and you actually had to say artificial intelligence. You couldn't say AI, or no one would know what you're talking about. And that was 2013. So now here we are a decade later, and the adoption is real. What, though, comes with that, and I think John was talking about earlier, is the compute platform it runs on. I mean, right now, NVIDIA is the platform, right? And the price of the GPU platform has gone up and up and up and up. And NVIDIA stock in 2019 was $30. It's now $300. That's a pretty big gain. And so I think the innovation in the next 5 years has got to be a competitive platform. So number one, a competitive platform to NVIDIA's. And it's hard because it's a very sticky platform, but you can see the investments that Google's been making in TPUs over time, right? AWS coming out with their own AI processing, matrix multiplication solution, but they're not at the competitive performance level of NVIDIA. And I think you're going to see a lot more custom silicon coming out of other large cloud companies like a Facebook or whoever, or cloud service providers. It's inevitable because it all goes back to efficiency, and it's incredibly inefficient because of the price that you're having to pay for the compute power. There's going to be a real appetite for acquiring companies that have innovations around the hardware space in AI. Those big guys are going to grab them, and then they're going to scale the platform and create some real competition. They have to.
Yeah, a competitive platform for NVIDIA is a big take. So hearing that, Paul, I want to move the mic to you. I would also ask, what is the most challenging innovations but will disrupt the market in 10 years? So both 5 and 10.
For 5, in the industry that I'm involved with, so the wireless telecom industry, we've gone through a set of different innovations to try and get the efficiency of the networks up and support all these cool things that now we've gotten to a point where we're actually moving the processing out of the end device and into the edge of the network, and that lets you do all sorts of really cool things. With XR, we're actually doing split rendering so that you can get photorealistic images on the devices on your headset, which you can't do because the headset itself is too constrained, but if you do it in the edge, you actually can get photorealism. And not only that, but the joint processing we do is also something that's the wireless network itself is in the edge. So I think that in 5 years in our industry, it's this joint processing and moving processing to the edge. In 10 years, I mean, look, also with my industry bias, the most valuable company in the world is based off of selling smartphones, and I think 10 years, I think maybe we will get to the point where the smartphone will be challenged by other devices that are more body-worn. Right now, obviously, they're big and dorky looking and all, and there's not a lot of applications, and the applications don't really let you work with each other, and they're not very realistic. You're talking about cartoon characters and all this stuff. I think that as soon as we get to a realistic representation of reality that you're interacting with both in real life and virtually, then it's going to be something that's important and life-changing. 10 years, I think, that's probably about the time frame that we'll get all those pieces put together by.
So Diane, you hear Paul mention the XR and novel edge device. What is your take on the 10-year question?
Take anything that is nascent today, and in 10 years that will become prolific. And you have to say, well, what's nascent today? ChatGPT, right? It's all generative AI. That's what everyone's talking about. There are real applications and real ways that it is going to drive efficiency. And I'm always hung up on the word efficiency, because if you can make something more efficient, you're going to be successful. The IBM CEO said a couple weeks ago that 26,000 IBM jobs are going to be replaced by generative AI in 5 years. I think 5 years is a little aggressive, but 10 years, So I think a decade's a magic number.
In 5 years, I would agree, and I will jump on what Diana's been talking about in terms of new computing architectures. We saw First of all, AI happening with regards to actuation, so the digital world meeting the physical world. And I know in the last session we talked about autonomous vehicles. We saw a lot happening in computer vision, and we saw that helping through actuation, the whole robotics industry and mobility coming out of that. And then as the neural net models got better and better, and as we started combining large language models with what had been done in natural language processing, we saw much more happening in the text space. And ChatGPT has provided a fabulous conversational interface so that the whole world is now talking about AI and playing with things like DALL-E for images and ChatGPT for text. But as Diane said, the compute required for all of that data and the architecture required for processing all of that data is tremendous, and the energy utilization in the data center is also tremendous, and the number of GPUs required. So as we were looking at Playground and looking at the 5-year period, we said, hey, we're going to need a much better architecture for faster inferencing. And the companies that want to build their own models and train on their own data are also going to need a training platform. So we invested in a company called D-Matrix that does an in-memory compute technology so that you have the memory and compute both in SRAM and can speed up inferencing at an order of magnitude with a far lower cost. And then as we looked at training, we realized these huge language models were going to be useful, and the very large corporations could build these very expensive models. I'm sure people have seen how much OpenAI is spending these days. But that many companies were going to want those domain-specific models that John was talking about. And instead of needing trillions of parameters, the sweet spot might be 3 to 50 billion parameters for domain-specific information that any enterprise might already have, and they may want to train on that. And so we invested in a company called Mosaic ML. It was, interestingly enough, the same team that had developed an earlier AI acceleration hardware technology called Nirvana Systems that actually Diane acquired while she was at Intel. And that team left and realized that there was so much to be done in software and building the software architecture and tools for training that they could turn 1,000 different knobs to optimize training. And so they created a company called Mosaic ML that is helping anyone, any enterprise, to build very, very efficient models and then train on them at a much, much lower cost and, very importantly, much, much less energy. Another area we really bet on in the 10-year time frame is quantum computing. And so we invested in a company called PsiQuantum. So in quantum computing, we saw ion trap technologies, we saw superconducting technologies, and then we were looking at photonics. And if you think about silicon photonics, the semiconductor industry has learned the process for manufacturing and fabrication for the semiconductor industry using silicon photonics. So it's a very, very well-known technology. And so we thought in order to scale to a 1 million qubit quantum computer, which we felt was going to be needed for the reliability and the scalability that would be required for true useful quantum computing for companies to use, we were going to need error correction and felt a 1 million qubit machine was going to be what was needed. So we invested in PsiQuantum, who is working with Global Foundries right now, manufacturing thousands of silicon wafers to produce the first useful 1 million qubit machine. Actually, their company is right down the road from here, and we started working with them and are a huge believer in the different workloads that quantum computing will solve, which are going to be quite different from the AI workloads that are so data intensive. And with quantum computing, it's going to be more math intensive, so different applications.
Yeah, so what I'm hearing is quantum computing, domain-specific silicons, and the large language model and training and inference. With the advancement of the generative AI in the past 6 to 18 months really have significant improvement in terms of the technology and applications. What are the unique cybersecurity concerns you see come out of it?
So, cybersecurity is an area we spend a lot of time in it as well. We're going to see much more sophisticated phishing, much more sophisticated ransomware, much more sophisticated spoofing of all kinds and spamming of all kinds. So, generative AI does have that side where determining the authenticity and the provenance of content is going to be absolutely critical. And we're going to need to see new technologies in determining digital identity.
If somebody can call up a financial, your financial person and look like you and say, here, transfer money to this account. We are going to have some digital identity solution. And you can imagine that it being a situation where you aren't even you unless you have some digital token that proves it's you. And if you lose that thing, you got to go somewhere where they're going to measure your biometrics and make sure it's you before they give that back to you again. Because, this question of having something that detects a generative AI generated thing, that's how they're built. They have these adversarial things that try and detect and fool and detect and fool. So it's just, that's cat and mouse game. So there's going to have to be something. And then when you talk about quantum is going to screw up all that crypto stuff. So yeah, we got a lot of fun ahead of us.
There are a few things that are being developed. First, if you haven't read the NIST, they came up with a risk management framework for AI, much like they had for cybersecurity. So there's a government effort. How many of you have heard of C2PA? No one. Okay, so there is a coalition of companies. It is called the Coalition for Content Provenance and Authenticity. So it was started by Microsoft, Intel, Adobe, Twitter, and other companies to develop technologies that could tackle digital provenance. And I was talking to Eric Horvitz on Friday, and he said they're actually quite a ways along. Of course, Google and Meta have their own efforts. As you can imagine, they've had to tackle this problem on their own as well. But he was actually fairly bullish, and many of these coalitions are involving academia and government and industry and scientists together to tackle these problems. They're certainly not going to be easy, as Paul said, but there are coalitions that are coming together.
Being in the healthcare space, those people are completely paranoid about cyber theft, given you're handling, PHI, personal health information. So the willingness to adopt technology starts with the over-conservative view of the risk of that data. So it's until we get stronger security solutions that can give those high-risk industries confidence, like the healthcare industry, it's going to be an inhibitor for technology adoption, and hence our healthcare system today.
Yeah, now I would like to switch gear a bit. Pao, I know XCOM is really in the middle of computing and connectivity. What do you see the recent innovations that will disrupt the traditional industry? And would you provide some specific examples?
Obviously, everybody lived through the 5G hype cycle, and that hasn't really panned out. But what actually did happen that I think is super interesting in the connectivity industry is sort of different licensing models for spectrum and for licensed spectrum or lightly licensed spectrum. And what that's done is that's going to allow the market to move from selling to a few, handful of mobile network operators with tremendous buyer power to a much more horizontal market where you can sell into enterprises. And that's, it is starting already. One of the things that we're working on right now that's cool is on the warehouse automation, where there's big racks that have all the merchandise in it, and mobile robots are running up and down in three-dimensional space, picking stuff up, taking it to a picker, and then the order that comes in, 12 minutes later, it's available. And you can imagine from a radio standpoint, there's a three-dimensional metal structure, stuff moving around, metal things moving around, so the RF environment's changing dramatically, hundreds or thousands of robots driving through this thing. So they needed a specific solution. They didn't need a general purpose mobile network operator solution. Maybe they needed some spectrum, but they needed something that managed handoffs, or eliminated handoffs and had high spectral efficiency so we can get all the information to the robots and back. So there's these super interesting applications of a private network. And obviously there's much more mundane things like just, going around and doing, inventory management. There's, all the utility stuff. There's factory automation. There's many, many things where there are companies that have a job to be done. They don't need the general purpose solution of a wireless system. They need something very specific and tailored. And so that, I think, is going to open up a lot more innovation in the industry because it won't be this one-size-fits-all. I think it's a big, big disruptive force in the wireless industry that will change things pretty dramatically. And then the thing that I said also, just this trade-off of using compute to get more efficiency of the network, because going back to spectrum, it's scarce and expensive and all those things. And so if you can use more processing power to get more throughput, then that seems like, that is going to be a fruitful area that will disrupt the industry as well.
I think one of the challenges I see that in this area is you always have very strong incumbent. What is the advice you have is, how the startup can capture the value in this space?
I mean, I think that's the interesting part, or the exciting part, right? Is a startup can have a strategic exit, whether that strategic exit is IPO or acquisition. And just like my point with innovation and startups innovating in AI hardware platforms, a startup is not going to get to market and compete head-on with NVIDIA, right? I mean, that's funny, right? So what's going to happen to those? That startup is going to be acquired by an AWS or a Google or a Facebook or whoever, because those people are always out looking for the next technology breakthrough, the next big idea, and you're much more likely to find that great new idea outside than within your four walls. I mean, we just see it over and over again. You have so many smart people in the world inventing things, and you have the large corporations watching. There's corporate VCs here, I know, and grabbing that. So just like that, in Wi-Fi or wireless or any kind of connectivity infrastructure, that is a heavy lift. That is a huge capital expenditure, huge. To think that a startup in this day and age is going to go to IPO and then compete head-on with the other technologies, it's much more likely to be acquired by one of those big folks that have the capital to turn that into an industry standard and drive the adoption curve. 17% of all startups end up with a strategic exit, 1% IPO, and 16% acquisition. So I don't know, if I'm a startup, I might just target the 16% instead of the 1%, but the 1% is fun too, right?
I think it's important that a startup either has an order of magnitude difference in terms of performance or in terms of lowering costs. There has to be that order of magnitude improvement or some new architecture or new foundation that makes it so appealing to customers that the order book starts filling up early on, and that is a better way to attract investment.
So having gone at Qualcomm from startup to mega cap, we had a better idea. There was a greenfield opportunity. People, it was the transition from analog to digital, so there was opened up a lot, and the people at Qualcomm were the people who really understood digital communications. I would also say, like luck played a big role in it too. So, the reason why it's so hard to get to that point is because a lot of things got to break your way too. So you got to work your rear off. You got to have to be the 1%, you got to work your rear off. You got to have a world-changing idea, and you got to be freaking lucky, and that your competitors, mess up, and all sorts of strange things happen. Like we had a competitor that chose their speech coder, because I did that work for CDMA. And we were like, why does that sound so bad? They went through this whole competition. Well, when I went up to run hours in the same lab that they ran theirs in, I found out that the lab had messed up all the samples. So they literally randomly chose a speech coder for the competition as opposed to the best one. So it just sounded bad. And that helped us. That was another thing that helped us win. It's just like little things like that are just so So anyway, so I guess the point is, like, you got to be very focused and have a great idea, and also like seize the opportunities when they come, because those opportunities, that's how you're going to wiggle through and find your way. But it's still extraordinarily hard. So.
We touched a bit about the medtech space. We already see many AI ML companies in this space, especially in the image processing applications for detection and diagnosis. So Diane, I would ask you, what are the unique computing and connectivity innovations in this space, and what are the unique challenges you see for this particular use cases?
You got to admit, if you're a really smart cybersecurity IT guy or really smart connectivity networking IT guy, the last place you want to go work is a nonprofit hospital. No stock, no chances of upward mobility. I mean, you talk about, so talent, of all things, becomes a huge limiter to in this industry staying up to speed. And so, as I said, cybersecurity risks are tremendous. There's a huge need to advance security, to give them the confidence, to advance the networks. We all engage in the healthcare industry, and it could be so much better with broader adoption of technology.
Laurie, you look at many AI ML companies. Can you shed some light on what are the typical pitfalls for startup to deploy their technology?
Some of the issues that I think the industry is grappling with, as we talked about in the previous session, is the biased data. If you are using one of the models that is outside of your company, one of the large language models built by others, there's a big concern that enterprises have if they, for example, put their code into one of the models or put their data out. Who owns the data? Who owns the output of whatever is generated? A lot of enterprises are much more excited about being able to have more of that control the output, and control the training data. But the concerns around bias and copyright and ownership and privacy are still of great concern in the AI ML world.
What I see as the biggest problem for startups in AI is the startup fundamentally has to have a moat. Like, one of the three fundamental criteria around a value of a startup is that you built some moat, you have some intellectual property. And the problem with software AI companies is you can't patent the algorithms, and the data sets, maybe you're lucky enough, as was said, to own them, but that's hundreds of millions of dollars. How many startups are going to be able to spend that kind of money on data sets? And so what is your core differentiation between you and the next guy? And we saw this in the radiology space, in image recognition, in reviewing x-rays, in identification of cancer and cancerous tumors. And there was the first to market, big industry leader, I won't say names, but big industry leader, first to market, at a certain price. It was $100,000 a year for a subscription to a hospital. The number two guy came out, dropped the price to $30,000, and the market flipped from 90% to the first guy to then less than 50% of the market, flipped overnight. Because AI is AI, image recognition is image recognition, data sets are data sets. So it is really difficult, and I think you really have to stop and think, what is that core differentiation? It's the intelligence of the people programming, right? It becomes who can get the best talent, who has the smartest talent, or who can actually find that high quality data set and maintain it as a proprietary asset. But it's very hard to come up with a real moat, I think.
Until the litigation is settled, we don't know about copyright and open source and how it's going to apply to these things, this generative AI generated code.
Any questions from the audience?
You've all had the chance to sort of run major enterprises, run aircraft carriers, and now you're doing different types of roles. And I'm just curious, which is more fun? I mean, maybe particularly from Paul and Diane, I'm sure there were frustrations in both, the big job, if you will, and the job now that you're doing. But which allows you to get more excited when you get up in the morning, and why?
You spend an inordinate amount of your time in a startup fundraising. And that is, I think, the worst part of the job. But on the other hand, in a big company, you spend an inordinate amount of your time on investor relations, which is probably similar.
No, I think you said in a big company, you spend most of your time on PowerPoint, which is also equally frustrating. But yeah, going from entrepreneur to entrepreneur, the obvious similarity there is you have to keep inventing or you'll die. Even inside of Intel, we have here someone from our silicon photonics team. We started a silicon photonics team inside of Intel for next gen connectivity. It went from $0 to $250 million in revenue within the year, and it was wildly successful. So whether you're in a big company or you're in a small company, if you aren't continually inventing, you're going to die. In a large company, in the data center group, I had 10 product lines, servers and storage and network and Ethernet adapters and whatever. And so it's highly complex, obviously high return. You go into a startup and you have one product for one target market with one customer base. And so life is so simple. I mean, it's like so simple. It's like hard to even believe how simple it is, except that you have single point of failure, right? If that one thing goes wrong, the whole company's gone. So it's like simple and stressful.
There was a period of time at Qualcomm where the investors wanted us to have non-revenue generating, things that were more than 2 years away in terms of generating revenue. And that was kind of like a golden period. And we invented a lot of stuff during that time, things that, absolutely changed the devices that we carry around with us because we had that freedom. And I know, dealing with like nonprofit research institutes, when they're curiosity driven, you get like these amazing results out of that. So I would say, in the big company, if you have the ability to do that, which we had for a time at Qualcomm, I think that was probably the most productive time of my career and probably the funnest.
I think my question is probably a little bit more toward Dr. Jacobs. Well, the telecom industry overall, from 3G to 5G, largely consolidated. And coming with that is a lot of consolidation of telecom equipment. And today, we actually don't really have a telecom equipment provider in North America. It's actually Nokia and Ericsson, and that 1/3 of the market is actually being controlled by Huawei. So as the world becomes a little bit more deglobalized, how do you think the reshoring of the technology, where do you think we should innovate and invest as a community?
Yeah, that's a great question. It's one that we're focused on at XCOM because we have, the hubris to think that maybe we could be the seed of a telecom player that could be a national champion in the United States. And the thing that I believe is that the way that the U.S. wins in general is through innovation. So it needs to win again through innovation and not just doing the same old. And what I said before about having a horizontal market where you can sell into, I think that helps a lot because the buyers, the mobile network operators, they've also consolidated a lot. And the period of time it takes to get through a mobile network operator is very long, and they don't really want to bring on new vendors that easily and so forth. So having the horizontal market that allow you to build out an equipment manufacturer and innovate to solve the problems that these various enterprises have. So that's the way I look at it. And then I think, at least from our standpoint, we see a lot of companies that are doing innovation in the space and need a platform to put those innovations on top of. So that is one of the goals that we have as well, is to try and be sort of that catalyst where that can come together. And there's a lot of interesting things going on, but it is hard to compete against an incumbent. We had a case where DoD was trying to incentivize small companies to come out and build new innovations, and they created a test bed down in Coronado, and they wanted a smart warehouse. Well, the test bed, which was supposed to be Open RAN and allow us to put different things in it and on top of it, ended up being won by Ericsson and AT&T. And I can tell you, none of the people who were working on network innovations got the next grant because it was absolutely impossible to innovate on top of that platform. So now it's hard for them as well. Those big companies, it's hard for them to innovate on top of their own platforms too. So I think that creates an opportunity. But like you said, it's hard to compete against those big guys. Yeah, and then just to close with where I started, innovation is the key. So if you can do something better than they can do and you can sell into a market that they haven't locked up, that's the best way to do it.
Andrew, we have any questions online?
Yes, we do. And the question is from Ali. And the question reads, are there any government initiatives or programs or regulatory bodies to regulate data sets or training practices of company-owned AI models?
The regulatory statement around data in healthcare is that if you can prove that the data will improve the efficacy, sensitivity, specificity, accuracy of whatever that healthcare device is, then you own the data. So if, Kaiser has a medical device and it's generating data, it's generating their patient's data every time they do an exam, that's obviously the patient's data, it's obviously the hospital's data, but FDA says it's also the company's data that is developing and building that medical device, because that data through AI can continue to improve the results. So I think that was shocking to me and actually quite generous, because now every hospital that has our system, we have to de-identify it. That's obvious, right? But the data that's of value is actually owned back by the company that owns the original device. Pretty nice. Pretty forward thinking of the healthcare industry around AI. Who would have thought?
I mean, we're going to have to find some kind of a balance. I actually think the market is going to drive some of this kind of stuff as well. That the regulator will be probably behind, as they often are, and come back later with hindsight and regulate. But I do think the market's going to be very sensitive to this issue about how much of your information is leaking out because it was used as a training set. And so that may be more the solution.
Thank you to our panelists for taking the time, share your insight and passion, and also to the audience for both in person and online. Thank you, everybody.